Okay, everyone. We're going to start the webinar right now. My name is Philip Bachand. I'm with Bachand Associates, and I was going to introduce Ashley Goldsmith. She's going to be our moderator. She's with Kings River Conservation District and part of the MAGSA outreach team. And so, Ashley, take it away.
Hi, everyone. It's so exciting to see everybody trickling in. I'm just going to give a few logistical details. For all of you who are watching today's webinar, your video and microphones are turned off and they will remain off for the remainder of the webinar. If you experience any technical difficulties, feel free to message us in the chat and we would love to assist you. Please only use the chat for technical difficulty questions. All other questions that you may have for our presenters and panelists should be submitted through the Q&A feature at the bottom of your screen. After each presentation, the presenter will respond to any questions that have been submitted, and I'll go over the Q&A feature on the next slide. But first, I just want to let you know that this webinar is being recorded and will be made available on MAGSA's YouTube channel and website as soon as possible following this event. We will also send a link of the recording to our email list. So if you would like to sign up for that list, you can head over to www.mcmullenarea.org to sign up, and I can drop that link in the chat as well. We can go to the next slide just to go over the Q&A details. So as I mentioned, if you would like to submit a question, please do so using the Q&A feature on Zoom. You'll hover your mouse over the bottom of your screen and you will see the Zoom menu pop up. Then click the Q&A button, type your question, and hit send. Questions will be answered after each presentation as time allows. And if we are unable to respond to all of the questions during the webinar, we will collect the unanswered questions and respond through email afterwards. If you'd like to ensure that your question will be responded to, please make sure not to send it anonymously. And with that, I will turn it back to Phil.
So I'd like to introduce Matt Hurley. Matt Hurley is the general manager at MAGSA, the McMullen area GSA. As you know, they are hosting this webinar for us. So I'd like to let Matt say a few words.
Well, my job is easy for today. I'd just like to welcome everyone to the webinar. You see the sponsors listed there on the screen. Happy to have them aboard at MAGSA. And we are very familiar here with OnFarm Recharge being sort of the home of the Terranova project as well, which you'll hear from Don Cameron a little later. But just glad to have you here and hope you enjoy the hour and a half. It's going to be very informative.
Thanks, Matt. So I just wanted to give a few opening remarks on. I'll try to keep this short. Number one, I wanted to thank everyone who's attending this webinar. We have a good crowd here. This webinar is the first in a series of educational and informational workshops that we'll be giving as part of the MAGSA, as part of the McMullen projects, and they will be focusing on OnFarm Recharge, Floodmar, and the McMullen projects. Today's agenda, we have two speakers. We have Sandra Bushon, who will be presenting on the results of a CDFA specialty crop block grant that studied the implementation of OFR, OnFarm Recharge, on pecans. And that talk will be followed by a talk by Professor Helen Dahlke, who will be talking about nitrate leaching and management under OFR to protect groundwater quality. We will finish the presentations today with a grower panel moderated by Dr. Mohammad Yaghmour. And interspersed through this webinar will be survey questions. The survey questions are part of the specialty crop block grant, and they're primarily focused on growers' interest and thoughts with regard to OnFarm Recharge and participating in it, and their interest is in applying it to nut crops and pecans. So for the questions that are only appropriate for growers or those working with growers, and if you are not one, then just let that question pass on the survey. So next slide. So the first survey questions are now.
All right, so as Phil mentioned, we'll be asking a series of questions throughout this webinar using Zoom's polling feature. So I'm going to launch the first question now and give you all just a few moments to respond. I see the votes trickling in, so I'll just give a couple more seconds. Okay, with that, you all should be able to see the results, and that's kind of how the survey is going to work throughout the presentation.
Okay, so next slide. So this first presentation is by Sandra Bachand. She is co-founder of Bachand Associates and a California registered engineer with over 30 years of engineering and research experience. Bachand Associates is an applied science and engineering water resources firm. This project developed practices to improve OFR efficiency and performance and demonstrated OFR on pecans. It was done in collaboration with UC Davis, UC Cooperative Extension, and Pacific Gold Agriculture. And Pacific Gold Agriculture also provided matching funds for the project. So with that, I will let Sandra go on with the first talk. Thank you.
Hi, I'm Sandra, and yes, I'm talking about this project on pecans, OnFarm Recharge, that was funded by NRCS Specialty Crop Block Grant. And we worked in collaboration with Ben King and Mike Powell of Pacific Gold Agriculture, and they are the ones that actually conducted the OnFarm Recharge and just had so many great ideas about ways to improve our methods. And also with Mohammad Yaghmour of UC Cooperative Extension and Helen Dahlke of UC Davis. Next slide. The outline today, I'm going to be talking about the motivation, why we're doing the project. I'm going to describe the study a little bit, and I'm going to describe how the growers put on the water for OnFarm Recharge, what our results were for how much water we put on, and other things, and just a short description of what we think the costs are. And this is going to be pretty quick because I have a lot of information. So next slide. So the reason that we are really interested in OnFarm Recharge is for groundwater sustainability, because with climate change, there's going to be less surface water stored in the snowpack and more variability of droughts and floods. And so the way that our reservoirs have worked, in which they can collect snowpack water coming slowly down in the summertime and then distribute that onto farms, isn't going to be as quite as good now with less snowpack. And so there won't be as much water available to farming, and that could actually result in less farming acreage unless we find somehow a new source of water. So OnFarm Recharge kind of offers a new source of water in that hopefully we can capture water that would ordinarily just leave the area in a wet year because it can't be stored by the reservoirs, and it can be distributed onto a lot of ground in order to recharge the underground reservoir of the aquifer. Pecans we were studying in particular because they are known to be able to tolerate saturated soil and flooding past dormancy. Next slide. There's 5,000 acres about of pecans in California, and most of the counties in the Central Valley do have pecans. So they are distributed throughout the Central Valley. Next slide. So this study was done in McFarland, California, which is south of Delano. This is a map of the site. We looked at 2 fields, field 20 and field 19. The soil underlaying this site is called Wasco sandy loam. It's a sandy loam interspersed with loamy sand. There's some gravel, and below this one area that you see in the map called 19W, we seem to see a very permeable, like sand with gravel layer that went quite extensive, and below about 4 feet. We did this study in 2 years, 2019 and 20, between the dates of like very early May to like late April, early May to mid-June. So like right after the leaves were on the trees to mid-June. We had 4 different treatments: continuous flooding, which was at 19W, that green triangle, where they were just trying to put as much water as we could. Alternate flooding, which is the little purple 19E area. And that we were doing a study where you're looking at alternating between 2 different subblocks. Those little green stars are where we had our monitoring station. And you can see that there's a star like right between the subblocks, and that was for monitoring a situation that would be similar to like an alternating row situation where you're irrigating every other row and then you switch. And we also did over irrigation. So that's just a treatment where you irrigate and then you irrigate again. That was about, that was done in 2020. So our monitoring stations, they were looking at soil water content, temperature, oxygen, surface water depth. And next slide. So the next slides are going to be about on-farm recharge methods. Next slide. The best way, I mean, the easiest way to be able to put water on for on-farm recharge is with existing concrete pipes that are connected to district water. But a lot, of farmers have transitioned to drip irrigation or mini sprinklers, and in some cases, those old concrete pipes don't work anymore. And so for this study, we chose to use a Polypipe system. Was connected up to district water. It's not that expensive of a thing to do, and it's very, you can take it on and off the field relatively easily. There, put gates in the polypipe that could be adjusted, so you could turn the water off or slow it, turn it on. And so that Polypipe system is on the bottom of that slide that shows the 19W, 19E. It's showing in the little map where how the water was getting put onto those plots. Next slide. So you have to control the water, or most of the time, and soil berms are a good way to control water when you are trying to prevent it from going somewhere, like to prevent it from going off the field or in some particular area. But there's also something that you might want to do called terracing in your field if you're trying to do on-farm recharge. And the point of terracing is to try to maintain a more consistent water depth across the field by slowing the water down as it goes down your field. And of course, the problem you might have with that would depend on how slanted your field is. But in this case, we did use those terraces. First, they tried putting in silt fences in 2019, the first year. Those silt fences, you can buy them pretty easily, and they come already with a little stakes attached. But still, there's some work in putting those in. The reason they can work as terraces is that the water is draining through the fabric slowly. And the second year, they used polypipes, the same kind of material they used for putting the water on the field, but in this case, they didn't have any holes in it or anything, and they just put it out, filled it with water with a water tank, And that dam was able to kind of like, form across the soil and really prevent water from moving across the dam. And they put PVC pipe under it in order to have a conduit for water to move. So in the first year before they put the silt fences up, they were able to get about a maximum like sustained level of water application of 4 inches per day. And after, they were able to get about twice that amount after they started using the Polypipe dam. Next slide. Results. We did see some wildlife, as you can see out there with the ducks in the picture. Next slide. So we applied as much as 41 feet of water onto the continuous treatment in 2020. There's a little bit of question in my mind about whether some of that might have been infiltrating a little bit off this toe area. So I made a range there of 27 to 41 feet. But I mean, we did recharge 215 acre feet in 2020. And because there was just so much water applied, the ET and those kind of deductions for recharge were not very significant for the more flooded fields, continuous and alternating. And of course, for over irrigation, it was more significant. We only put a half a foot on. Next slide. So when you flood the fields, you might expect the water content in the soil increases and oxygen levels decrease. This seems to happen pretty fast. I don't have a number right here with me, but it's pretty quick that you start seeing especially at 1 foot, a change in water content and oxygen level. The average drop rate of this oxygen dropping was about 1 to 1.5 kilopascals per day. As a reference to what I'm talking about, 21 kilopascals is the partial pressure of oxygen in irregular atmospheric conditions, and 10 kilopascals is given by some as the optimal. To be over 10 kilopascals is considered more healthy for a tree than to be below that number. So considering in this location, the drop rate being 1 to 1.5 kilopascals per day, it would, if you started at really dry, fairly dry soil at 21 kilopascals, it would take about 7 to 11 days to drop down to a level that might be harmful, 10 kilopascals. Next slide. And then when you put the water off, oxygen starts to recover pretty fast. Our average rates that we saw out here were 1 to 2 kilopascals per day when the oxygen levels were really low. So if you're below 10 kilopascals, it'll take about 1 to 2 kilopascals per day to get up to above this 10 kilopascal level where we think it's probably relatively healthy. So if you were at 5 and you went from 5 to 10, it would take about 2.5 to 5 days to get back up to 10 from 5. Next slide. So what did we see? I'm focusing on oxygen conditions because I think that that's kind of what people are concerned about. We saw that oxygen levels dropped to 0.5 kilopascals. So that was the low that we saw. And that's compared to 0.8 in just a regular irrigation that was happening at the same time, in that same time period on another field. And how long were these levels low? They were low for about 15 days in the flooded fields for the first year and 24 days in the second year. And in the over-irrigated treatment, they were only low for 2 days compared to the regular irrigation where it was only low for 7 hours. Is there a way to keep O2 levels higher during OFR? Well, we did find that at the continuously flooded field, which happened to be underlain by this very permeable soil, the oxygen really dropped much slower. And so if you're able to find a very permeable area, then that's going to be a really good place to do on-farm recharge for all sorts of reasons, but including the oxygen level won't go as low as fast. And in general, if you are concerned about oxygen levels, we found if you allow the, if you take the water off and allow it to dry briefly and then repeat, you can like reduce the duration of this low oxygen. So for our study, we found that like 5 or 6 days was plenty to bring oxygen levels up above 10 kilopascals, well above, and reduce that the amount of time below that level. And also we found that levels were generally a little bit higher in the alternating row kind of treatment, where if you're going to irrigate every other row and then switch to every other row, maybe because oxygen is able to enter. I think that oxygen is entering these systems from maybe sometimes below to the side, not just from above. And so when you have that kind of drier area next to you, that is providing like a source of oxygen. Next slide. So we have we established that we had some really low like long periods of low oxygen, and pecan trees are supposed to be able to handle that because they can, not supposed to be, the theory is that they can, and the theory of why they can is because they can metabolize toxins and accelerate their anaerobic respiration. Now these protective measures are probably dependent on when flooding occurs. So for instance, in a study in New Mexico, Talistad et al. Found that that those pecan trees did exhibit some health problems. They were flooded from mid-July to August for 35 days. And the symptoms that those trees exhibited were leaf bronzing and altered nutrient absorption. Now for this study, we were looking at late April to mid-June. So it's a different time period. And we partially, based on this information from other studies, we evaluated like visual assessment, leaf nutrient analysis, stem water potential, and yield to like assess tree health. Next slide. Quickly, this slide here, this picture of the trees was taken on the last day of OnFarm Recharge on the second year, on the most flooded field, the continually flooded field that had just gotten all that water. And those trees look, as far as we could tell, they seemed like they look really good. So we did not see any signs for our visual assessments of any problems. With leaf analysis, again, we took a leaf analysis in mid-May, and then after OnFarm Recharge was over, and we didn't see any like negative impacts. You can read this more detail, but from the leaf analysis. We looked at stem water potential, which might indicate it might indicate a problem with photosynthesis and transpiration, or maybe poor root health but the stem water potential in the flooded fields during the study, this was done in 2020 when Mohammad did the stormwater potential measurements. In 2020, did about every couple of weeks, and he didn't see any problems. And so if there was going to be a problem with the root health, maybe that would have shown up even from 2019 in that work. And we looked at yield, and yield, it seemed to be about the same or higher for some reason in field 19, the flooded fields, as compared to the control field 20. So the conclusion is that we did not see any effect on health on these trees from all of this water. Next slide. Additional benefits real quick. If you were to have a salt problem, which they did not have here, but this does, of course, as you might imagine, reduce your salt in the root zone. And it also, really importantly, it means you don't need as much irrigation, because during this time period of April to mid-June, we were doing on-farm recharge, but we were also not having to irrigate, of course. We were not having to like pump groundwater to irrigate. And after it was over, those soils were wet, so it took a while before we needed to do another irrigation. So not only are you doing the recharge, kind of on-farm recharge, but we're also doing the in lieu recharge of like, instead of taking water out of the ground, we're just using water that is not groundwater. Next slide. Quick cost. We think that this cost of 6-week OFR was about $35 to $200 an acre, and that with the higher number, if you needed to put out, that was be what you need to spend. If you needed to put out the Polypipe system for getting water onto the field, and then put on the Terra system, and for the cheaper $35 an acre number is just if you need to hire an irrigator to spend a few hours out there a day. Next slide. So in summary, we put up to 40 feet of water onto that 5.4 acre plot. Oxygen levels did drop during that on-farm recharge, but we did not see any impacts on the pecan health or yield. And we did see that there are ways to shorten the duration of low oxygen using appropriate on-farm recharge management practices, and like also siting practices, and that these like ideas about management are transferable to other crops, not just pecans. Next slide. Questions and more wildlife photos.
So if anyone has any questions, they could put them up. We probably have time for a question or two. And you'll be able to ask questions later as well. So being that we have no questions posted, I'm going to move on to this second survey. Ashley?
All right, I just launched the second survey, which has 2 questions. I'll give you about a minute to respond. All right, I'll give about 10 more seconds. And Phil, I also saw we have a couple questions that have trickled in. All right, thank you all for participating. You can take a quick look at the results, and I'll turn it back to Phil.
Yeah, so there's a few questions. One is, is oxygen as important in the dormant season? I don't know if Sandra's able to answer that, or if we're better off having Mohammad pipe in on that one.
It's probably better if Mohammad, I don't think it's as important, but I'd love Mohammad to answer that if he can.
For which question?
Is O2 as important in the dormant season?
So as long as it's not affecting the root health, then usually the trees are dormant during that period. So we don't expect the low levels to affect the trees that much. So I don't have a direct answer for it, but I don't expect that it's affecting it during the dormant season.
Okay. There's another question is, what effect did on-farm recharge have on residual nitrates in the soil? And it goes on, you mentioned the yields were the same compared to the control, but were the fertilizer treatments equal? How do you think this will affect adding nitrates to groundwater?
You know, for the information that I had, fertilizer treatments were equal, or like, it seems like even a little less in the really flooded fields, because they couldn't get in there as easily. And we don't have that. We are going to get results about nitrate leaching as part of this project that Helen's lab's working on that, but we don't have the results of that yet. And do I think, and the other question was, do I think it's going to have what was the other portion of that about?
Do you think this will affect adding nitrates to groundwater?
I mean, I think that it's important to think about where you put on-farm recharge, and to I think it's probably important to try to use the same fields over and over again, so that you're not flushing a new, cleaning out a new orchard every year. You want to use the same fields, and then if you do flush nitrate to groundwater, you're also flushing just a whole lot of really clean mountain water also.
There's a question on the source of water used in the study, Sandra.
Oh, yes, that was the the North Kern Storage Water District was the source of water, and yeah. In 2019, it was like, there was extra water. In 2020 was a little bit of a different story, that I think they had to use some actual well water, probably from the water district.
There's a question that's in the chat that I'm going to bring up. Which elements of this research are transferable to other crops, likely not crop tolerance for in-season flooding or over-irrigation? I'm not sure exactly how that question is, but basically, what's transferable to other crops, Sandra, on this?
I think the information about like how fast oxygen is dropping. I mean, of course, it's going to be different depending on your soil type, but and how like different treatments, maybe like doing the every other row might be helpful. Those things about management of methods of on-farm recharge to reduce your duration of oxygen being low. As well as, of course, the methods that these that Ben and Mike came up with for how to how to put a lot of water on the field with like the terracing.
Was Phytophthora present in the water? Do we know?
Was what?
Phytophthora. I think maybe Ben King would be able to answer that one a little better.
Yeah. Hi. Thanks. So, as far as we know, there's no evidence that pecans are subject to root Phytophthora. It's a different cultivar. It's part of the hickory family, and it's not subject to Phytophthora.
Then I'm going to look at one more of these questions. The other ones we'll answer later. One is regarding leaching. Did we see any leaching from field 20 to 19, or any effects on leaching on the results in 19?
We did not see any leaching onto 20 from 19, like increased water, or no, not at all. And what was your other question?
It was basically, I think it was a follow-up that was asked, was there any effect of field 20 on the results of field 19?
Or field 19 on field 20?
Vice
well,
versa,
I mean,
too.
Probably just having any source of oxygen around like a dry area is probably a good thing. But I don't think it really affected the middle of the field, field 19, having the dry field to 20.
Okay, so yeah, so make sure when you ask questions that you ask them in the Q&A. And if there's a question that was in the chat, maybe you want to transfer that over to the Q&A as well, so that we can keep track of it and make sure we answer it. And so next slide, please. So I'd like to introduce Professor Helen Dahlke for this presentation. She's an associate professor at UC Davis in the Department of Land, Air, and Water Resources. She does a lot of research, and I'm going to summarize it in one sentence. For researching, well, part of it includes studying the interactions between hydrology chemistry and biology chemistry as related to California water resources and the related management and societal implications. and that is like some percent of her research. The work here she is presenting was supported by the Almond Board and others. Helen, it's great to have you here. Thanks.
Thank you, Phil. And hello, everyone. Good to have you join this little webinar. So yeah, my talk will be a nice follow-up on Sandra's presentation. She already talked a lot about some of the concerns that we have when we do on-farm recharge in perennial crops. In my talk, I will focus a little bit more on some of the decision support tools we're in the process of developing, and I'll talk a little bit more on the nitrate leaching aspect of the on-farm recharge. Next slide. So on-farm recharge on idle land in the winter is pretty straightforward. However, there's not really much known about how perennial crops such as wine or table grapes, or tree crops such as almonds and pistachios are really coping with waterlogged conditions during the dormancy. So on the right side here of the slide, you can see a table on the tree crop vulnerability to saturated conditions that's based on expert opinion, not really experimental studies or research. And this was mainly put together by interviewing farm advisors here throughout California. But depending often on the rootstock that you have for your trees, it's perceived that some crops such as almonds or wine grapes and pears can tolerate standing water up to 2 or 3 weeks. And so again, this is really an area of research where we really need to do more work. There's really not much known on the crop tolerance of most perennial crops. And so I work with the California Almond Board to investigate the tolerance of almonds in response to winter recharge. And so for this research, we instrumented 2 almond orchards, one located near Modesto, the other one near Delhi. In both orchards, we applied 2 feet of water over the course of like 3 to 4 irrigation events, so typically flood irrigation. One of the sites is shown here on the left. This one had a fine sandy loam soil texture, while the other site at Delhi was a dune sand, so really sandy soil. And so both orchards actually had nonpareil almonds planted, so we were mainly watching how the yield of those almonds responded. Next slide. So at both sites, we were interested in studying the tree response to winter recharge, as well as potential effects of the intentional flooding on nitrate leaching and nitrogen cycling in the soil. And we conducted these particular almond recharge experiments for 3 consecutive years between 2015 and 2018. Next slide. In this slide, you can see the stem water potential measurements taken during the growing season of 2016 after we had applied 2 feet of recharge at both sides. That recharge was typically applied in December or January. And so in this stem water potential plot, you can see here the recharge treatment is shown as a blue line, the grower standard on a black line, and the baseline as sort of a black dotted line. So we observed slightly higher stem water potential in all recharge treatments in the winter at both sites. However, for the fine sandy loam, we did not see significant differences in tree water status going forward into the growing season. For this soil type, the extra winter water really had no effect on tree water status later in the growing season. But for the trees in the recharge treatment at the sandy side, we see a slightly higher tree water status in May and June compared to the grower standard. On the right side, you can see the yields obtained at each site for the 3 years of study. In general, trees in the recharge treatment at the sandy site showed higher yield, while at the fine sandy loam, we did not really see discernible effects or differences except for 2017, which was an exceptionally wet year with a lot of rainfall well into April. So we had rainfall during the bloom, and we had also rainfall, well into the season when the trees were already leaved out, where oxygen depletion might have been an issue on tree health. Next slide. At the Modesto site, which had the finer textured soil, our observation showed that it took definitely longer for the recharge water to really pass through the root zone. So it took quite longer to drain, as illustrated in the bottom middle graph. In general, you can see here the volumetric water content plotted in response to 1 6-inch water application. And you can clearly see that the sandy side, top left, drained much quicker. It took about 6 hours for the water to move through the profile, while the fine sandy loam took more than 48 hours for the applied water to drain through the root zone. Next slide. So soil drainage and hydraulic properties play a large role in determining how much water can be effectively recharged at a site. But for perennial crops, the other concern, as already alluded to by Sandra, is that we need to take into account the slow depletion of oxygen in the root zone, which if we have low levels of oxygen or even anoxic conditions, can inhibit root respiration. Root respiration is the uptake of oxygen by the roots, but low levels of oxygen can also affect soil microbial processes that, for example, control the conversion of nitrate into nitrous gases, a process known as denitrification. Most of the time during the year, the soils are typically aerated, so they contain air, oxygen, and there is a constant exchange of gases between the soil and the atmosphere above. However, when we start flooding the soil, we apply water, and that water acts sort of like a lid or a barrier, preventing the entry of oxygen into the soil. And then the actual depletion happens because root respiration and microbial communities are actually consuming oxygen to stay alive. And so we kind of looked into this a little bit more recently and developed a simple model that allows estimating a safe flooding duration that takes the drainage properties of the soil into account and estimates the time it takes until a sufficient amount of oxygen is entering the soil again after drainage. Next slide. So on this slide, you can see here on the left, this concept of the safe water application duration. The oxygen content is shown as a blue line in the top graph, the water content shown as black line in the bottom graph, and then the water application time itself is shown as a blue filled color. You can see here that even if you switch off the water, of course, the soil is still saturated and needs to drain from the profile below a critical water content, which is also shown here as a green circle, at which point air is starting to re-enter the profile. So the time it takes to reach this critical water content at which air or oxygen can re-enter is shown here for different soil textures on the right. Please click. So in this graph here, which is showing this critical water content and drainage time for different soil textures, if we look at this graph here, for example, we can look at the sand texture in the bottom left plot. It takes about 2 to 3 hours for the water to drain until we reach that critical water content when air can re-enter the profile. The horizontal dotted line below that shaded part shows the critical water content. For a clay loam, however, top right graph, it takes about 20 days until you reach that water content when oxygen enters the profile again, which is likely too long for most perennial crops to tolerate. So we're in the process of making this little tool available on the web as part of the SAGB index to provide more guidance for growers. And you will then have the opportunity, for example, to pick a crop, the tolerance that we know for that crop, and you can then compare, or you get an estimate of what is roughly the water amount we expect you can apply safely for a given duration to risk or to avoid the risk of oxygen depletion, harmful oxygen depletion in the soil. Next slide. Another concern of on-farm recharge is the potential to leach residual nitrate that's present in agricultural soils due to frequent fertilizer applications. And that nitrate, of course, can leach to the groundwater. So during this almond recharge experiment that we conducted, we also took 16 feet long soil cores from each side before and after the recharge event and estimated the residual soil nitrate content. This slide here shows the residual soil nitrate load in the root zone or upper 3 feet of the course we took for the 2015-16 season. And you can see clearly here that the sandy side had very little residual nitrate left after the recharge. And in fact, we leached on average 89% of the residual nitrate we had present in the soil prior to the recharge. For the fine sandy loam, the story was a little bit more complicated. We actually saw higher residual nitrate load after the recharge. And this was indicative that the 4 water applications we did in Modesto over the course of 4 weeks, we flooded the orchard every Monday with 6 inches of water, provided optimal moisture conditions for microbes to convert organic nitrogen into inorganic nitrate, a process called mineralization. Next slide. This slide here shows a year-to-year comparison of nitrate loads for the sandy side. And so for the entire 2016 feet soil core, what you can see here is that during the second recharge winter, 16-17, the residual nitrate load in the part of the orchard that was flooded for recharge in the previous year was already very low compared to the control. But again, we did leach more residual nitrate in the second application or the second winter event. Again, 2016-17 was a wet year, and we could see an increase also in the nitrate load in the control. And again, this is most likely due to mineralization of organic nitrogen to nitrate, which does need quite a bit of moisture to really happen at optimal conditions. Next slide. So because we saw this, next slide, please. Is it coming? Yeah, patience, okay. So because we saw this increase in nitrate after recharge, we decided to do some laboratory column experiments to really look into these processes in more detail. And we were mainly interested in answering 2 questions. So how much water or nitrate was transported from the root zone towards the groundwater table? And then what type of nitrogen transformations are occurring in these flooded soils? And on the right side here, you can see a graph of the most important nitrogen transformation processes that we would expect under on-farm recharge, which are the mineralization of organic nitrogen from organic matter into nitrate, nitrate leaching, and then potentially denitrification of nitrate into nitrous gases if the soil is waterlogged and depleted of oxygen. Next slide. And please, yeah, click again. Thanks. So yeah, we conducted a total of 4 soil column experiments using the sandy soil from Delhi and the fine sandy loam from Modesto, and we tested 2 different flooding frequencies. The first one, which we call the low frequency experiment, in this one we applied 6 inches of water every 1 to 2 weeks, just as we did in the field. And then we did a higher frequency experiment where we applied water every 72 hours and then, measured all the known parameters like water content, oxygen content, nitrate in the water and in the soil. Next slide. What we found was that in the experiment where we applied water every other week, more nitrate was leached from the soil column with the applied water than was initially present in the soil profile before we started flooding. So we more or less observed the same results or the same phenomenon as we had seen in the field. And this is again indicative that that the higher water content that you get with the recharge and then the periods, the longer periods between each water application really provide optimal conditions for mineralization of organic nitrogen to nitrate. But we even saw that for the sandy soil as well. So in the fine sandy loam, this phenomenon was more strong. So in this one, we saw about 146% of the initial nitrate leached, meaning more than 50% of the leached nitrate was actually produced between flooding events through mineralization. Reducing the flooding interval to 72 hours reduced the amount of nitrate that was mineralized. We just couldn't, we didn't give the microbes enough time to really produce it. And as a result, you see less nitrate leaching. So all of this is, of course, for pulsed flooding. If you do continuous flooding, you, of course, deplete the oxygen over, the duration of a couple hours or days. And then in that case, you often actually see denitrification happening, which is another way of reducing nitrate from the system. Next slide. So to wrap it up, some of the big takeaway points here. Pulse flooding of almonds showed no significant effect on yield, and growers on well-drained soils might actually really think about or appreciate that opportunity that large amounts of water can be recharged in almonds. To keep the risk at a minimum, you may want to do that really during the dormant season, and you may practice this maybe in areas where you see flood water becoming available less frequently. So maybe not where it's available every year. Flooding can create short-lived anoxic conditions in the root zone. So to keep flooding, to keep again the flood or the risk low, I recommend keeping the flooding duration below the root zone residence time. Again, we'll have a tool on this on the web within the next 3 months probably. Winter recharge can produce nitrate in the root zone through mineralization of organic nitrogen, which might reduce fertilizer needs during the growing season. So we shouldn't necessarily look at this like extra nitrate as a negative. You actually should think about taking advantage of it and reduce synthetic fertilizer applications, and soil testing, particularly at the beginning of the growing season, can help determine how much residual nitrate you have in the soil, and then you could adjust your fertilizer needs accordingly. And in our studies, most of the nitrate that was present in the soil leached within the first couple hours of water application. So there's actually not really much we can do to retain that nitrate in the soil, so it can be taken up by plants or the crop later in the season. Thanks. Next slide. Thank you very much.
Okay, so why don't we go to the next slide, which is the survey. Oh, here's the references for Helen, the survey. And then while the survey is being is out, and people can also enter their questions in, and then we'll come back to Helen with some questions.
Perfect. I just launched the survey, and you can also spend some time entering your questions in the Q&A during this time.
Do you want me to answer the first question, or?
Yeah, sure. There's actually two. The first one was the 1223 question, and then the second one you could start answering. Yeah, sure.
Okay. For the almonds during flooding events, how was runoff avoided? How was runoff measured? So we also bermed the parcel or that plot where we did the recharge. So you typically go in with like a what is it called? One of those little tools that can, carve out the soil and then pile it up. And the berms were about 12 inches high. And then how was runoff measured? So we are always reliant on the local water district when we do our recharge experiments. In this case, we had the Delhi site received water from a groundwater well. So we had a pump and we had a flow meter on that one. For the Modesto side, we actually received flood water from the Modesto Irrigation District. And there was a ditch tender who basically said, now it's time to shut off. So we don't have, because we had existing flood irrigation infrastructure, it was very difficult to actually install a flow meter on that one. So, but that orchard was flood irrigated during the growing season anyway. So I trusted the irrigation manager that he knows what 6 inches is.
Okay, another question was, is recharge in research pilot project phase currently, or is this a technique ready for farm application? So can we do it now, or do we have to wait?
No, you can do it now. I think there's a lot of information already out there. There is also the DWR organized FloodMar network. And I think that group is in the process of also putting sort of an online knowledge database together where, you know, interested growers might find a lot of information. The Almond Board has information on this. Sustainable Conservation has several guides that they have published. So it's really, what I usually recommend is, like, if you're thinking about it, start talking to your local water district, because you have to go into sort of a small little marriage and discuss how you can get water and, you know, yeah, where to put it.
And then there's another question: in pulse flooding almonds, what is the best duration for pulse flooding based on average sandy loam soils?
Yeah, so when we do pulse flooding, we typically use rather an irrigation depth as sort of a threshold instead of a duration, because you are limited in the ponding depth by the berm height that you are putting, you know, the height of the berms that you're putting around your plot to keep the water within the area. So we typically did not exceed a ponding depth of like 6 or maybe 8 inches. And that was, you know, so typically what we would do is open the flood valve and let the water go onto the field maybe 3 to 4 hours until we reach those 6 inches, and then we shut it off and let the water infiltrate. Yeah, and so depending on the drainage characteristics of your soil, you could maybe, you know, if you have a sand, you have a sandy loam, so it might not be as fast, but I would assume that water still infiltrates within like 6-8 hours or so. So you could, you know, do that almost on a daily basis, and then just watch if it still goes in or not. If it's not going in, then I would probably increase the time interval of the water applications.
Okay, so that's the last question that came in for you. So why don't we, if there's any additional questions people have, just keep putting them down, and we'll get to them. If not later on this webinar, then later we'll respond. But why don't we move on to the grower panel now? And it's being hosted by Dr. Mohammad Yaghmour. He's the Orchard System Advisor for Kern County Cooperative Extension, and he provides expertise and research support as well across the nut and fruit crops. And he will introduce and moderate the grower panel. Mohammad?
Thank you, Phil. Again, my name is Mohammad Yaghmour. I'm the Orchard Systems Advisor here in Kern County. Today, we are fortunate to have 3 growers joining us for this panel to speak about their experiences with OnFarm Recharge. Today, we have Don Cameron of Terranova Ranch, Mark McKean of McKean Farms, and also we have Ben King from Pacific Gold Agriculture. I would like to start this panel by giving the chance to our grower to introduce themselves. So we're going to start with Don Cameron. Don, go ahead, please.
Thank you, Mohammed. It's really good to be with everyone today. So my name is Don Cameron and farm at Terranova Ranch. We're located about 30 miles southwest of Fresno, and we farm a real variety of tree crops, almonds, walnuts, pistachios, olives, and wine grapes, along with another 15, 20 different row crops here. So I'll let Mark go ahead.
Thank you, Don. Mark McKean. We grow several crops as well. I think the focus of today will be almonds, because that's where we did the bulk of our work here in the recharge area. So we'll get into the details of that, I'm certain, soon. Ben?
Yes, hi, I'm Ben King. My family's been farming in Colusa County since 1860. We grow almonds and pecans, and our pecans are in McFarland.
Thank you, Ben. So to start this panel, I would like to ask the growers, the first question is, why do you do on-farm recharge, or what made you participate in such work? Don?
Yep. Thanks, Mohammed. I've been interested in on-farm research, on-farm recharge for quite a number of years, and have been working toward the goal of actually doing on-farm recharge for probably over 30 years. We've seen the groundwater table decline 1 to 2 feet per year, and knew that that's not sustainable. This was way before Sigma. So we embarked on we had a small grant, worked with Phil Bachand, and in 2011 started by doing on-farm recharge on wine grapes. Again, in 2017, we expanded that. The next flood period we had, we expanded it to almonds, walnuts, pistachios, and olives for oil. So in California, as you know, we're experiencing a terrific drought period right now, but we know that we will have floods in the future, and really to make California water resilient throughout the state, we need to be able to capture these waters, get them in the ground, and use them for periods like we have today, where we're in an extreme drought.
Thank you, Don. Mark, do you have any insights?
Yeah, very similar to Don. I mean, just seeing the groundwater tables drop and recognizing that that's not a sustainable practice, we needed to do something. Just began to give this some thought back in the early 2000s, began to really get serious about it. And when floodwater was available in 2011, did some on-farm research, nothing at all technical like you've heard about earlier today, but just kind of some farmer research as to how and when and where we can do these kind of things. And I will admit to you right off that not all soils are conducive to these types of practices, but we do have some soils on our farms that are, and we focused on those and started some processes, like I say, in 2010 to put things in place, develop and think about how we're going to do it. And 2017 was our first real year when floodwaters were available to our on-farm recharge.
Great. Ben, you have participated with us with the Pecan study. Do you have any extra points to share with us regarding this question?
Yeah, so I think that on-farm recharge is a very important tool for sustainability of water in California. You know, I grew up in Sacramento Valley next to a flood zone next to Sacramento River, and I think actually it's a natural state. Prior to reclamation, to some extent, on-farm recharge just replaces the way nature worked before reclamation. And so the reason that I got involved actually was at an almond board conference where I met Phil and Helen and wanted to basically prove the point that we can do on-farm recharge, and also there are certain sites and certain crops that may be more suitable to it, but with a real focus on just supporting the innovation and the people like Don and Mark who have been pioneers and pushing this, and with Phil and everybody. So I think it's a great effort we want to just be supportive of.
Indeed, it's a great effort, and all this work would not have been happening without, you know, the support of our growers, and you represent that support here during this panel. So my second question will be, What is the major problems you guys have encountered during the on-farm recharge, whether it's cultural problems, etc.? Don, we can start with you.
Thank you. Yeah, there are issues that you need to be aware of when you're going down the road to do on-farm recharge. But one of the first ones we came across was the infrastructure. Many of the areas that are groundwater pumped don't have the infrastructure. Some of the irrigation districts that already have canals and delivery systems in place, it's a much easier problem to address. But really, you have to look at your groundwater, your structure below your fields. You may have, if you have a clay layer that's impenetrable, that could really affect the value of the recharge to begin with. But we were concerned about movement of salts, any nitrogen, and also pesticides, herbicides to the groundwater. And we understood that that could be an issue, and that gets you over to management criteria that you really need to have in place if you are going to do groundwater recharge. You don't want to go put a bunch of nitrogen out and then find out next week you're going to have to flood a field. You want to hold back if you have any opportunity to do groundwater recharge of any applications. And I think it was said earlier, the difficulty of getting in a field if you need to do a treatment. I know we had issues with trying to control powdery mildew in wine grapes back in 2011. When we flooded almonds, there were certain applications that we needed to get on. And then we tend to pull the water, get the operation done, get the water back on the field. But it was ironic that when we went to flood some of the almond fields, we've relied on drip irrigation in our trees and even in our row crops, and we've kind of left laser leveling out of the equation for quite a few years, and we found that the distribution of the water in the almonds was fairly irregular. And so what we try to do now is, if we're going to laser level, if we're going to level a field, we try to level it flat, so that if we do have the opportunity for recharge, we'll get even distribution of the water throughout the field, so that we get better infiltration.
Good points, Mark. Did you also face any challenges?
Yeah, I mean, Don did a good job of pointing some of those out. Let me just take that one of them a little step farther, because I probably do it a little bit differently here in the efforts. And this is similar to what Helen referred to some of this in her talk as well. I was fortunate I had the infrastructure to get the water to the field, but then it's a matter of how you handle it once you get it to the field. And for us, as I mentioned, we had done some talking and some research back in 2010 and 11. And so from that, what we do is we put our trees up on pretty high berms. And so it looks a little awkward when you get started and neighbors kind of wondering what the heck you're doing over there. But it's in an effort to try to control the water. And as Don mentioned, we do a pretty fair amount of leveling, laser leveling previous to planting trees within these berms. For us, we found that a little bit of fall actually works better for us. We put about a 0.015 fall on most of these sandy loam fields that we're doing this in, and that seems to help get the distribution. It also helps with the timing of the run of the water, and also helps with getting the water evenly dispersed from the head down to the tail of those same areas. So those are some things you got to think about. For us also, you're talking about two different systems. We have a drip system in these fields, but we also have a flood system in these fields. Added cost, but once again, something for us, we just feel we had to go in and do to try to make this work. So it's not real simple in some cases, and some of the methodologies that were talked about here earlier are great temporary things. But for me, I really wanted something permanent. When floodwaters come available, you don't always have an opportunity to pick up the phone, get a purveyor to bring you out some tube or all the different systems you may need. So I wanted something permanent that I can rely upon and quickly and engage once floodwaters are available. So that meant the two systems. Some of the other concerns I had, obviously, and this has been talked about earlier, is plant health, is the phytophthora issues. I think that we're getting through those. I'd certainly like to see some more research on rootstocks and how that affects with potential on almonds, with potential of fighting off some of these diseases. Obviously, nitrogen leaching, that's an area that I think there still needs to be some additional research in as to, you know, the typical UC guidelines are about 33% of your nitrogen needs in post-harvest and fall applications. For us doing on-farm recharge, I don't think that's a good number. I think we need something less than that. And I think it'd be so good to have some research as to how much less of that we can stand, and then do the catch up after we get going with our recharge projects. For me, it's the flood water is pretty much always available sometime between January and about 1st of July. And it's hit and miss in there, sometimes on, sometimes off. So we have to kind of deal with that as according to nitrogen. But the whole leaching is still some work that I think we'd like to have some more information on, particularly when it comes to state water board staff and whatnot, who may not like what we're doing if they find out that we're leaching. So we've got to fine tune it so that we have some information to combat those charges of leaching. So I think those are some real big challenges. Another one that I would consider too, that I think all of us have to face, is just scheduling. That's the same time of year when we all know we're very busy trying to get bloom sprays on, berm sprays, those different things. Scheduling becomes a real hectic problem when you're trying to do on-farm recharge. Something that you really got to consider strongly how it works for you. But not all soils are going to make this conducive to this, but certain soils do. But there's a whole lot of things, like more of a list I can go through, I'm sure, but I'm probably out of time for that answer. So I'll pass it on to Ben.
Thank you, Mark.
Thank you, Mark. So I'd like to just support what Don and Mark had said. I think what's really clear is that it's a very complicated process, but I think we need to look at two things. One, in a Mediterranean climate, you know, timing is everything, and you have to be prepared. And it's also like a field of dreams. You have to be prepared to take it, and so that takes really foresight. It takes coordination. It takes investment. And I think the two growers here have been doing it for a while, and they've been doing it because they have the scale and they have the foresight and basically been able to take the risk, or been willing to take the risk. And what we need to do is scale what's been done across the state, within watersheds, within irrigation districts, and find the best land to do this, and then find growers who will do it. So, you know, my purpose in the on-farm recharge of pecans just show that it's a cultivar that's suited for recharge and theoretically could be flooded from January, probably from February on to the middle of June. And there may be pecan growers in your GSA who'd be willing to do this, but you need to then provide the water. So it's a very complex solution, and we learn more by doing. But I think we have to really go forward that and learn from what growers like Don and Mark have been doing.
Thank you all. Indeed, as we move on with on-farm recharging and getting it adopted more and more, definitely we will need more research looking at all the aspects and the challenges you guys have mentioned, whether it's cultural practice or in terms of diseases. So my last question to you is, how would you like to see on-farm recharge being fit into Sigma? So Don.
Thanks. Yep, no, good question. We know that Mark and I are both in a critically overdrafted sub-basin here. And, you know, there's many critically overdrafted basins throughout the San Joaquin Valley. And that's a real concern, because all of us want to continue to farm the acres we farm today. And if there's a way we can get this water into the ground, it's going to be helpful for everyone within our sub-basin. So we started on this way before Sigma was a part of the equation, but now that it is, I think it's going to be up to the individual GSAs to work out a system between their growers and their agency. And this is all, Sigma is local control, so you'll probably see very to see a variety of ways that GSAs will handle this throughout the state. But I think that this is a very important part of SGMA and will help build sustainability throughout each GSA that adopts it.
Indeed, Mark?
Yeah, I think obviously every agency, every groundwater sustainability agency is coming up with methodologies to try to achieve their sustainability. And this is just one, and it's not for everybody. But I would hope that, I don't want to oversimplify here, but I would hope that each GSA would look at this methodology no different than, say, a recharge basin, with the exception of the ET that's obviously used by the trees. So in that, I would hope that there would be some kind of a recognition, a reality that the recharge should be credited back to the grower in some manner or another into the final budget that one proposes to do. The reality of it is it's going to look a little different because of the availability of floodwaters, at least for us, the availability of floodwaters in certain years and not in others. But that's what I would hope, is it would be recognized as a methodology for recharge.
That's true. Ben, do you have any comments?
Yeah, so I would say, picking up what Mark said, I think we really look at a net ET. Because growing orchards provides many multi-benefits, including pollinator habitat and just almonds themselves or other nuts, providing food, plant-based protein, and it's better to a large extent. My personal opinion is that the natural state, especially in good recharge zones, we had riparian forests and really orchards, in a lot of ways replicate those multi-benefits. So if you look at net ET, that's how we should look at it. So in our project, we were getting infiltration rates about 10 inches a day, assuming a probably conservative ET coefficient. I think our use was like 0.3 inches. So we're getting almost over 9 inches a day of net ET. And we can do that probably from February on to the middle of June. And so a grower who's willing to risk or make the investment should get some type of recharge credit, whether in their GSA. And then, and so, the point is really that we are really replicating probably natural systems, and we're just growing food on places where there was just riparian forest before. And a lot of these areas are best suitable for recharge. And then I also just want to point out that we really should also lift up growers who work on soil permeability within their own orchards, because the best water delivery system is Mother Nature itself. And to the extent that you work on whether or not cover crops or other things that actually can improve permeability and keep that water within your orchard, there's just multi-benefits of that. And I would hope that the GSAs work toward getting credits for just working on just capturing rainfall within the orchard itself and looking at things like soil health and multi-benefits. Because this is a natural thing in California. During the winter time, water comes either from the sky or from the rivers and goes back on our aquifers, and we need to move back to that. And on-farm recharge, to me, is just a replication of what the natural state was.
Thank you very much, Ben. I would like just to let our participants know that, if they have any questions to our growers, to feel free to ask those questions in the questions and answers section. And Phil will be able to moderate those questions. With that, I would like, to thank our growers for their time and their efforts. And all their help with the research, whether with the university or other entities. We will not be able to do what we do without the help of our growers. So to that, thank you very much. And if anybody has any questions, please go ahead and place those questions in question and answers tab.
Wonderful. Thank you so much, Mohammed. As you are submitting your questions in the Q&A, I'm going to launch our final poll, which has a series of 5 short questions. So I'll give you a little longer this time to respond to those questions. And again, if you have any questions specifically for a grower panel, feel free to submit those in the Q&A right now.
We have a couple more minutes that we can accept questions if anyone wants to put them forth to the panel, or anyone else for that matter. If you note in your question to whom it's to. I'll open this up. If any of the presenters or anyone else participating had a question, they could ask. There's one that's has come in. One person has asked, what was the effect seen on groundwater from surface water application? And I would like Don to answer this from what he learned in 2019, I think it was, or 2017.
Thanks, Phil. Yep, we had several vineyards we flooded, and we actually had a monitor on a well right in that location. We ended up putting about 13 acre-feet of water on the vineyard that season, and we saw a 40-foot increase in groundwater levels right pretty much in the middle of where we were doing the groundwater recharge. So it was fairly impressive with the amount of water we put on.
If any of the other panelists want to talk about this, I don't know if Mark or Ben have anything to say.
You know, Phil, for me, I got to tell you, you know, I'm convinced it was helpful. As to how much help, that's something that we obviously need to get a little more entailed in, and some monitoring wells of some kind. But I'm convinced we did do some good. But as to quantifying that is something we need to get some more research on.
Yeah, so I would add that Yolo County Flood Control District actually has real-time monitoring wells, and they have a canal system that they use really for essentially a recharge, and it's really clear when they're actually their waters in their wells, waters in their ditches, the groundwater goes up. It's probably been documented for several years now, but it's very clear that works from the point of having water in their ditches. So to the extent that you start putting waters in the field, it should be commensurate with that.
There's a question here. Have we seen any studies done with pistachio trees?
Sorry, what was that, Phil? Could you?
Have we seen any studies done with pistachio trees? And I think you could answer that one.
Yes, we flooded pistachios for several months. They were, I think the trees were probably, I think they're around 7-8 years old. You can't see it now, but we had a watermark that was 2 foot higher than the berm. And so the water was deep, we kept it on for quite a while. I was nervous about it because I've seen trees that have had issues on heavy ground. Our ground is light and does drain. We did not see a problem with it. And like I say, I thought if we were going to have a problem somewhere, it would be with pistachios or with the olives, which are both very, they're able to withstand droughts, I mean, and not die. And we flooded our olives, super high density olives, and our pistachios for quite some time, and we did not see a problem with it. So I think the potential's there. And like I say, this was during, what was it, May and June. So I always am concerned. I think we, you know, the colder the water is, the more oxygen is being held in the water, and I think the less effect it has on your trees. It seemed like, you know, when we were flooding wine grapes, when our air temperature hit, you know, in the 90s, our water temperature increased, and we had some issues there. As soon as we pulled the water, 10 days later, beautiful vines, dark green. So you can't, I tell you, you can't just put water on, walk away, and hope it all works right. I think you really need to be vigilant if you do this, especially during the growing season. You need to watch your trees, look for any symptoms of issues or nutrient deficiencies that may show up. So just be careful. There's not a lot of data. I know that there's a lot of data being developed, but you know, as growers, we take risks every day, and this is another one that we do. So
I'm going to take the liberty of asking 3 more questions. I want people to keep them short because we're running up against a timeline on this, but I think these 3 questions are really interesting and are a little bit higher level. One was, do you think ag lenders and investors see growers who are using recharge as a less risky investment than farmers who are not working to mitigate their water risk?
I'll go ahead and take that. I mean, I think the lenders are aware of Sigma, and they've been looking at water sources for quite some time now. And I think that if a grower is being proactive and trying to improve their water situation, I think they look at that as a positive. Like I say, you know, the majority now like to have 2 water sources, but that's not always possible. I think this helps supplement, you know, what a grower has in his repertoire for water.
Yeah, I think lenders, investors, I think everybody is with the knowledge of Sigma on the forefront there. I think they're paying attention to all these different methodologies. And you know, for me, I do get calls from different lenders every once in a while about what my thoughts are as to how this is going to play out and what's going to be available to them as tools and what's not. And so, yeah, I think they're very aware of that. And I don't think it would be outside of their possibilities to even lend on some of these systems that might help a grower in the future, because they do see this as a serious threat and also see some of these methodologies that we're working on as potential tools that they could help them out to get repayment. And that's really what they want, is repayment.
Yeah, and I would say if the GSA actually endorsed it, or the irrigation district endorsed it, and actually proactively, the lender investors would be all over it, because then they think it's a good idea. So if you got a collective support for it, it's going to be spun as a positive.
Okay, the next question I'm going to ask is for those diverting floodwaters, are diversions occurring through an individual water right or an agency's water right? Any thoughts on that? Whose water right are you using?
Phil, I'll go ahead and answer. For me, it is a permanent water right, and I have the ability to use that water right for recharge.
Yeah, I think there's a lot of different situations throughout the state. You know, there are temporary flood permits from the State Water Board that are being granted. There are irrigation districts that have their water rights that will deliver water to the growers. It's a very wide mix, I think you're going to find throughout the state. And every area has different rules, different regulations. I just think you need to work with your current agency.
Yeah, and I would just add is that again, what we've done with reclamation is we've taken over probably over half of the recharge area and made it not accessible to natural recharge and taking away the flood zones. What we really should be focused on is taking the water when it's there and getting it in the ground. I know there's all the water right issues and regulatory issues with that, but ultimately we only have so many wet years. It needs to be in the ground, and to the extent the GSAs can find a way to work with the State Water Resources Control Board and come to a conclusion, that's great. But the focus should be is getting the water in the ground during the wet times, which will not have any detrimental effect to downstream users of the environment, because it's actually too much water at those times.
So the last question, and maybe we can start with Ben on this, because he just mentioned the State Water Board. Is there any thoughts on how the State Water Board could support maximizing recharge with flexibility around how much can be captured, stored, and recovered?
Yeah, I think State Water Resources Control Board obviously could have probably the most important impact, and because they control the permit process. So I think to the extent that they can give more and more latitude, to give more and more flexibility within their regulatory constraints and their policies and objectives, that's the best place. But I think it's let's start giving the most latitude and then increase over time, backed by science and policy considerations.
Anyone else?
Yeah, if I could just add on to Ben there, I'm sure it's saying very much the same thing. I would hope that they would see that this is a groundwater recharge and all the things we're trying to do here are a living, dynamic part of this world, and it's a give and take. And there may be certain components of this that they may have problems with, but are we getting better in other areas that may make sense for the long-term viability of agriculture? So, and municipalities as well. Remember, a lot of this recharge water goes to them as well. So I would hope that they would understand that and develop policies and procedures that allow such things to happen, because it's one of the only tools we may have.
Yeah, and I'd like to add from a point of Sacramento Valley, where we've had historically much more flows and in wider areas, that I would say that recharge is almost unnecessary, because the base of fresh water is challenging in some areas, from total dissolved salts and then other issues like naturally occurring contaminants like arsenic. And my concern is actually, if we don't have the recharge, we're going to find movement of those naturally occurring contaminants into the freshwater aquifers, because we've changed the recharge of the Sacramento Valley so much by reclamation.
Yeah, one other comment I'd like to make on, we're talking about permitting, and the State Water Board has the ability to allow maybe a little deeper down in the peak of these flood flows, maybe be a little more flexible with that water, and really maybe take this on a watershed by watershed basin, because the dynamics change in each area. If we narrow it down to a certain time period, you may be missing some real opportunistic flood flow periods that are available to growers, by boxing this into certain dates when when there is available water. So it'd be nice to, like I say, flexibility would be really good to incorporate. And I know everybody's cautious; they don't want to overstep their bounds, but I think the flexibility would really be helpful.
Mohammad, did you want to add any closing remarks to the panel
Again, I would like to thank our growers for being here and answering all those questions. It's always great to hear directly from our growers about their experiences. I agree with all our growers that we need more and more research on this subject as we go and as we try to adopt this practice for the future. So my last remarks is I would like to thank them. And again, we would not have done any of those advancements without their participation. So thank you very much.
And thank you to UC Davis and Mohammed. Great to work with.
Thank you.
Yep.
Yeah, so let me close this up for today. Obviously, we'd like to thank everyone who participated in this. We have a great group of people here who made time in their days and put together effort for this webinar. We also thank all of you who came in, took some time out of your days to attend this seminar and to participate in the surveys. We hope you found it useful and informative. This is part of the McMullen OnFarm Recharge Project's outreach effort. That project is moving right now to encompass 40,000 acres for availability in on-farm recharge with funding from the State Water Board, as well as federal NRCS funding through the RCPP program, as well as significant local match by the community down here through MAGSA and others, private landowners, etc. In that project, we're trying to develop planning and implementation tools for farm applications. We're trying to link it to the Sigma environment. We're trying to make it a forum for addressing some of the OFR issues and developing the science and technology to move it forward. Don't hesitate to reach out to any of us, all of us. Our contact information is available on this webinar, as well as we're all easy to find. We will send out answers to the questions that we're not able to address. This presentation has been recorded and is available at MAGSA, and we look forward to future webinars from the MAGSA team. And thanks to all, and have a good rest of the week. Thank you.
Thank you, Phil.